Welcome in this e-learning class. Now here, few instructions whenever we are starting out a lecture, that you must have notebook in front of you, pen, pencil and required things you must have. You must sit in relaxed position. Relax means what? In order to write down very easily. Don't sleep and observe the lecture, but usually keep in mind, if we are sitting out in erect posture, then the understanding capacity is more. So try to sit in erect posture and observe. Now whenever I am writing out something on board, try to understand first and then try to write down. Now you have control in your hands. So first listen carefully, and suppose you want to write down, then pause this video and write down whatever you want to write down from board. The important thing is that certain calculations you must carry out along with me. Whenever I am saying that we have to calculate, then try to calculate, try to understand and calculate. Don't copy out only. So this is very important. So whenever we are discussing or whenever we are starting out any calculation part, first try to understand and then carry out with your pen on notebook. Certain sums I am giving to solve for you. Every time in beginning I am reminding you that pause this video and calculate yourself, then observe, because I am going to solve that sum. But first try to solve yourself and then observe that whether you are correct or I am correct. So this is a simple technique you have to follow. Now henceforth, in first few lectures I am going to instruct you that okay, pause this video, but then onwards we are having now rapport. We can carry out easily that okay, this sum is there. You yourself will pause this video and calculate. Now whenever we are giving out certain tables, no doubt they are there in your notes, they are in the textbook, but still what is my idea, that you can pause for a while and take out that table, because that will help to understand the concept more easily. Hello. Now we are starting out simple part in mathematics, that how to remove decimal. Whenever we are carrying out fractional calculation, many times we have to shift decimal either towards left or right. Let us discuss this with help of a multiplier, that is 10 to the power of something. Let us discuss this point clearly. Say I am writing 10 to the power of 1. What is meaning of that? That is equal to simply 10. Now 10 to the power of 2, that is equal to 10 into 10, that means 100. So there is 10 raised to 2. I have to write 1 and 2 zeros. Whatever the indices is there, that I am writing here. Now 10 raised to power of 3, that is equal to 10 into 10 into 10. So answer is 1000. And so on. So 10 raised to n, that is equal to 0, 0, 0, 0, 0, like that, n times 0. So this 10 to the power, that is very helpful while removing decimal. Now this part is very essential. With this we can write down any biggest number very easily. So I can write down this way, 10 to the power of 1000. What is the meaning of that? That is equal to 1, 0, 0, 0, 0, like that, thousands 0. So huge figure, I can increase 1 0 over here, the value is still increased, and like that. And so these types of calculations are very easy if you are able to convert with help of 10 raised to something. Now let us discuss how to remove fraction or how to shift out decimal from one point to another. Let us check out now 5.678. I have to remove this decimal. That means I have to write down this figure as 5678. In this format, I have to write this. What I have to do? Simply divide by something, because I don't want to change the value. Now, I have to shift this decimal one place, second place and third place. In order to that, I have to write in this way, 1 0, second 0 and third 0 on 1. Now here very important thing is there, we have to calculate decimal places and that many zeros we have to write down. So this figure in whole number I can write this way. Now that is equal to 5678 divided by, now you are aware 10 raised to 3, that is equal to 1000. So count zeros and write down this way. Now one law that you have learned in school level only, that 1 by a raised to m, that is equal to a raised to minus m. So same way I am converting this, that 1 by 10 raised to 3, I have to take it at numerator. So it will be 5678 into 10 to the power of minus 3. Here it is 10 raised to 3, here it is 10 raised to minus 3. I am following this law, we are getting this answer. So here I have shifted out decimal and I am getting answer like this. So this is the conversion from fraction to whole number by keeping values same. So we have to multiply by 10 raised to minus 3. So from that it is very clear. Suppose I am shifting out. Now every time you should not carry out this many calculations. So just look here. I am shifting out decimal 3 places. So I am giving multiplier as 10 raised to, and how many places I am shifting out? So here 3 places. That means I am giving here minus 3 because I am shifting out decimal towards right. Now let us check out this example. That 5678. That same figure I am taking, and now I have to write down in form of 5.678. What I can do, because I don't want to change out the value, and so I have to multiply by something. How many places I am shifting decimal? Originally this is the place of decimal, 1, 2 and 3. So I am shifting out decimal 3 places, so I have to multiply this by 1000. Then the value will remain same. So this means I have to write down 5678 into 10 to the power of 3. That means I have to shift out decimal towards left. Then I have to give that places in positive number. So here, suppose I have to shift out decimal towards right. What I can do? 10 to the power of, and minus indices is there, and number of places I want to shift. So here I want to shift 3 places towards right. So I am giving multiplier as 10 raised to minus 3. Here I want to shift 3 places towards left. So I am giving multiplier as 10 raised to plus 3. Now is this okay? Any doubt here? Just if you are having doubt, revise this lecture, revise this much portion once again to get clear. If it is clear, then try to solve this simple sum I am giving. Try to find out or try to convert this as into 10 to the power of something. Just try to convert yourself first. If it is okay, alright, otherwise just observe. I am shifting out decimal 1, 2, 3, 4. So here I am shifting out decimal 4 places towards right. So as I am shifting out decimal 4 places towards right, as we have carried out same thing here, that 4 places, and as I am moving towards right, I have to give here negative. So this way I can convert this figure into entire number or whole number with multiplier 10 raised to minus. Now same way, if you are able to follow, try to convert 6.7888. I have to write down, 67888. I have to write down this figure as 6.7888 into 10 to the power of something. So I have to shift decimal 1, 2, 3, 4 places towards left side. So as I have to shift towards left side, it is 6.788. 4 places towards left. So give multiplier as 10 raised to 4. So this is the simplest way that we can remove fraction. I am understanding it clearly that few students are having clear-cut logic. But there are many students, especially in school level, they are having somewhat threat. They are afraid while calculating in terms of fraction. Now here, whenever we have to calculate any basic calculation or say higher level calculation, And if you are having fear of calculating in fraction or in log table calculations also, many times this problem is there. So what is my simple opinion, that you can follow this technique, that convert it into 10 to the power of and make that number whole, then carry out calculation, because we don't have fear when whole number calculations are there. So calculate in whole numbers and then just adjust out the power. This is the simplest way we can calculate complicated calculation in simple manner. Just you must aware of this technique, how to convert fraction into whole number or whole number into fraction by using 10 to the power. Now let us start discussing some fundamentals. Now we are trying to understand the conversion and calculation with help of metric system or SI system of length unit. So we are aware 1 meter is equal to 1000 millimeter. So I am taking out this way calculation, that 1 meter is equal to 1000 millimeter. Now you are aware that instead of writing 1000, we are writing out this as 10 raised to 3 millimeter. So 1 meter is equal to 10 raised to 3 millimeter. Now let us calculate on basis of this further. 1 millimeter is equal to, we are going on lower level. So 1 millimeter is equal to 10 raised to 3. This is called as micrometer. This is the Greek letter and we are pronouncing it as mu. So 10 raised to 3 mu m, that means 10 raised to 3 micrometer. So 1 meter is equal to 10 raised to 3 millimeter. 1 millimeter is equal to 10 raised to 3 micrometer. Now 1 micrometer, that is equal to 10 raised to 3 nanometer. So still useful unit, that nano stands for very small. So 10 raised to 3 millimeter, 1 millimeter is equal to 10 raised to 3 micrometer. 1 micrometer is equal to 10 raised to 3 nanometer. And 1 nanometer equal to, now there is actually unit picometer, but we are not going at that level, because whatever is useful for us, only that much we are going to calculate. So here I must write 10 or write say 10 raised to 1, and the name of unit, are you aware of this unit? Those who are studying out science, they are aware. This is angstrom. So A, and we have to write down 0 on top of that. So this is called as angstrom. So 1 nanometer is equal to 10 raised to 1 angstrom. Now higher units. In terms of writing higher unit than meter, the prefix means what? Whatever we are writing out before that or beginning of word, that is called as here prefix. So 1 kilometer, this K must be written in capital. That means what? It is higher unit. So 1 kilometer is equal to, this is 10 raised to 3 meter. Suppose I have to write down, then I must write this way, that megameter. So 1 megameter, that is equal to 10 raised to 3 kilometer. Now in the world of computer, you are also aware, the next is giga, then next is tera, and so on. So here, keep in mind, this is also mm and this is also mm. But what is the difference? Here I am writing with capital and here I am writing with small. Why? The smaller mm indicate lower unit of meter and uppercase, that will indicate higher unit. Now with this much of data, you have to by heart. No, by heartation is very simple. Just keep in mind 10 to the power of 3 only in terms of angstrom. Why we have discussed till angstrom? Because atomic radius or diameter is in order of angstrom. And whenever we are studying out physics or chemistry at atomic level or nuclear level, the angstrom unit is most widely used. And therefore we have calculated till angstrom. Now let us discuss how to convert out one unit into another, or say angstrom to nanometer, nanometer to micrometer. Like that we have to change out this. So that will help us to understand 10 raised to power of calculations also and this type of unit. So two things we are carrying out simultaneously. Now we have discussed that 1 meter is equal to millimeter, micrometer, nanometer. Now we have to convert out that 1 meter is equal to dash dash angstrom. So direct relationship between meter and angstrom we have to find out. Let us check. 1 meter is equal to 10 raised to 3 millimeter. I hope you have taken out this table. So look in the table also while I am discussing. 1 meter is equal to 10 raised to 3 millimeter. But 1 millimeter is equal to 10 raised to 3. What is this word? Micro. We have to pronounce like mu, but this is micrometer. So 1 millimeter is equal to 10 raised to 3 micrometer. Now 1 millimeter is equal to 10 raised to 3 micrometer. But I have now 10 raised to 3 millimeter because we are converting out 1 meter. So 10 raised to 3 millimeter is equal to 10 raised to 3 into 10 raised to 3 micrometer. Is it okay? Very simple thing. Just look here once again that 1 meter is equal to 10 raised to 3 millimeter. That means we have 10 raised to 3 millimeters. 1 millimeter is equal to 10 raised to 3 micrometer. Therefore, 10 raised to 3 millimeter is equal to, that means I am multiplying this side by 10 raised to 3. So I have to multiply this side also by 10 raised to 3. So this is 10 raised to 3 into 10 raised to 3 micrometer. Now you are aware of the law that a raised to m into a raised to n is equal to a raised to m plus n. So follow this law and we can get answer that 10 raised to 3 millimeter is equal to 10 raised to 3 plus 3, that is equal to 6 micrometer. That means 1 meter is equal to 10 raised to 6 micrometer. Now you are aware, in front of you chart is there and the brilliant student, they have highlighted this chart. I am aware that 1 micrometer is equal to 10 raised to 3 nanometer. Therefore, 10 raised to 6 micrometer, because we have now 10 raised to 6 micrometer. So 10 raised to 6 micrometer is equal to 10 raised to 6 into 10 raised to 3 nanometers. That means it is equal to 10 raised to 9 nanometer. Now 1 nanometer is equal to 10 angstrom. Therefore, we have 10 raised to 9 nanometers, that is equal to 10 raised to 9 into 10 raised to 1 angstrom, that is equal to 10 raised to 10 angstrom. So we have now answer 1 meter is equal to 10 raised to 10 angstrom. Now pause this video and take this down, and please keep in mind, you are clever, you are brilliant, intelligent, but still take out as it is. Why? That will helpful to understand concept more clearly. And so take down it is as it is. Pause this video till okay. Now try to solve the next sum similar fashion. That we have to find out 1 kilometer is equal to dash dash nanometer. If you are very good in calculation, you can calculate very easily. If you are, or say were not good, but now you are able to understand, then try to calculate this sum first. Same way, previously we have calculated same way, try to find out this sum. Till that, pause this video, calculate and then check out that whether it is correct or not. I hope you must have able to carry out successfully. Now just check out. 1 kilometer is equal to dash dash nanometer. So first, 1 kilometer is equal to 10 raised to 3 meters. 1 meter is equal to 10 raised to 3 millimeter. Now I am having 10 raised to 3 meter. That means multiply this side by 10 raised to 3. So multiply this side by 10 raised to 3. And you are aware now that is equal to 10 raised to 6 millimeter. Now 1 millimeter is equal to 10 raised to 3. And try to recollect micrometer. So 10 raised to 6 millimeter is equal to 10 raised to 6 into 10 raised to 3 micrometer. That reading is 10 raised to 9 micrometer. Now 1 micrometer is equal to 10 raised to 3 nanometer. Therefore 10 raised to 9 micrometer is equal to 10 raised to 9 into 10 raised to 3 nanometer. That is equal to 10 raised to 12 nanometer. That's my work. 1 kilometer is equal to dash dash nanometer. So answer is 10 raised to 12 nanometers. I hope you are able to calculate this successfully. One more practice sum. Simply calculate the relationship between 1 kilometer equal to dash dash angstrom. And carry out this relationship yourself first. Till that, pause this video. Try to calculate from beginning. Don't jump out here and there. How to jump I will show. But try to calculate. I hope you have calculated successfully. Now just check out. Now I am jumping because I have carried out this work once again. So from 1 kilometer till nanometer we are aware. Now from nanometer onwards we have to find out till angstrom. So 1 nanometer is equal to 10 to the power of 1 angstrom. Therefore 10 raised to 12 nanometer is equal to 10 raised to 12 into 10 to the power of 1 angstrom. So that is equal to 10 raised to 13 angstrom. So we are having answer as 10 raised to 13 angstrom. I hope your answer is correct. Now this is somewhat simple calculation. Now let us check out the reverse way of calculation. We have established relationship between 1 kilometer and nanometer, or 1 kilometer and angstrom. Now try to find out 1 angstrom is equal to dash dash. Let us check out. 1 angstrom is equal to dash dash meter. No doubt that first we have checked out this relationship, that 1 meter is equal to 10 raised to 10 angstrom. I can use this way, that divide both sides by 10 raised to 10. Because 10 raised to 10 by 10 raised to 10, that means here I am getting 1. So 1 angstrom is equal to what? That I can find out from this way. So 1 angstrom is equal to 1 by 10 raised to 10, that is equal to 10 raised to minus 10 meter. So this is simple way of calculation, but I have to explain other concepts also. So I am giving elaborate answer over here. This is the shortcut method, whereas we are going to discuss now elaborate answer, that 1 nanometer, that is equal to 10 angstrom. There are 10 raised to 1 angstrom. Therefore 1 angstrom, now what we have to do, divide this by 10 raised to 1. So divide this side by 10 raised to 1. 10 raised to 1 we are dividing, that means multiplying by 10 raised to minus 1. So 10 raised to 1 minus 1 nanometer. So I am establishing relationship between now 1 angstrom and 1 nanometer. Now same way, that 1 nanometer is equal to, cancel out this step, 1 micrometer is equal to 10 raised to 3 nanometers. Therefore 1 nanometer is equal to 10 raised to minus 3 micrometer. What we have to carry out, divide here by 10 raised to 3. So divide here by 10 raised to 3. Dividing by 10 raised to 3 means multiplying by 10 raised to minus 3. Therefore, now we have 10 raised to minus 1 nanometer. So 10 raised to minus 1 nanometer is equal to 10 raised to minus 1 into 10 raised to minus 3 micrometer. Multiply both sides by 10 raised to minus 1. Then we are getting this way. So that is equal to 10 raised to minus 4 micrometer. Same way carry out next, that higher unit of micrometer, that is millimeter. So 1 millimeter is equal to 10 raised to 3 micrometer. Divide this side by 10 raised to 3, this side by 10 raised to 3. So we are getting relationship between micrometer and millimeter. Now we have 10 raised to minus 4 micrometer. So multiply both sides by 10 raised to minus 4. 10 raised to minus 4 micrometer and 10 raised to minus 3 into minus 4, that will be 10 raised to minus 7 millimeter. Last, higher unit of this. So 1 meter is equal to 10 raised to 3 millimeter. Therefore, 1 millimeter is equal to 10 raised to minus 3 meter. Same way. Now as it is 10 raised to minus 7 millimeter, so multiply this side by 10 raised to minus 7. So 10 raised to minus 7 millimeter is equal to 10 raised to minus 10 meter. That means LHS we have started out from nanometer, from angstrom. So 1 angstrom, that is equal to 10 raised to minus 10 meter. We got the answer. So this way we can practice out very easily this type of reverse calculation. Now one calculation from your side, that 1 angstrom is equal to dash dash kilometer. Try to find out that 1 angstrom is equal to dash dash kilometers. So I hope you have calculated it nicely, that 1 angstrom is equal to dash dash kilometer. Previously we have calculated 1 kilometer is equal to 10 raised to 13 angstrom. Have you calculated this? So on basis of that, I will explain simply 10 raised to 13. So divide this side by also 10 raised to 13. Therefore 1 angstrom is equal to 10 raised to minus 13 kilometers. I hope in school days you must have studied science with interest. If not, learn now. Very simple techniques are there, but certain fundamentals you must aware. Now let us discuss some fundamental part from motion. You are aware that certain entities we have to explain on basis of its units as well as direction. And for certain, direction is not required. Say for example mass, I can explain in terms of kilogram. Length, I can explain in terms of meter. But whenever I have to talk of displacement, suppose one person is standing at the center of ground. He is standing and he moved 5 meters from that center. Find out his exact position. Can you able to find out? Say this is the ground which is supposed to be, we are planning out a circular one. This is center of that ground and that person is standing on center of this ground. And then he moved 5 meters. Find out its location, his location. Now this is the center position. 5 meter is the distance. Suppose this is the distance as 5 meter. So he can be here, 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 anywhere. So I can say he can be anywhere on the circle of radius 5 meter, center from that 5 meter radius. Wherever the circumference is there, on that circumference of 5 meter radius circle, he may be anywhere. But suppose I am saying that person is moved 5 meter towards north, then it's obvious this is suppose north direction, then I can give exact position. This is called as displacement of person. So for displacement, only unit is not sufficient. With unit, direction is also required. Now let us check out another example. One car is moving with speed of 60 km per hour. Another car is moving with speed 61 km per hour. So first car is having speed 60 km per hour. Second car is having speed 61 km per hour. What is the result of collision? Suppose both cars collides on each other. Then what is the result? Now we can check out this probability. First thing, that car with 60 km is moving in this direction, and car with 61 km is moving in this direction only. Then what is the result of collision? And check out, the car with 61 km is moving in this direction and 60 km per hour that is moving in this direction. Then what is the result of collision? In both the cases, the result of collision is different. So, here we have to explain the concept that only speed, that is kilometer per hour, is not important. Apart from that, direction is also important. And so, certain entities which are depending on direction also, they are called as vectors. So, what is vector? The entity which required unit as well as direction, that is called as vector. The scalar requires only unit, no direction is required, then that is called as scalar. Just in this discussion only, I said velocity of that, and then suddenly I said sorry, no, speed of that. What is the difference? Velocity is vector quantity, whereas speed is scalar quantity. What is the velocity? Displacement in unit time. You are aware displacement means what? The difference between initial position and final position. Whereas speed is distance upon time. Suppose in map you can able to observe this is Mumbai and this is nearby surrounding area. Somewhere here Pune is there. This is Mumbai. I have to travel from Mumbai to Pune by train. So, we are not traveling in this direction. From CST, our train will move in this direction. Pune is in opposite direction. We are moving towards north. Then we are crossing out this creek. Then there is Kalyan. Then we will move towards Karjat and then towards Pune. So, this is the distance travelled by my train. Whereas, this is the displacement. Suppose I am having helicopter and from CST I am simply rising out helicopter here and travelling in straight line, then what is the difference? This is called as displacement. Whereas whatever travelled by train, this is called as distance. So, if I have to calculate the speed of train, I can say that Karjat is somewhere 100 km and then almost 60 or 70 km, I don't recollect, that 160 or 170 km we have to travel, or more than that also. Let us imagine 200 for our simplest calculation, and train will take 4 hours for this journey. So what is the speed of train? That is 200 km is travelled in 4 hours. I have to carry out per hour. That means I have to divide this side by 4. Suppose I am dividing this side by 4, then I have to divide this side also by 4. So, I am getting 4 1 ja 4 5 ja 0. So, 50 km per hour, or say 1 hour. So, what is the speed of train? 50 km per hour. No doubt, this is average speed. Whereas, velocity. Suppose on map, the accurate map, I am taking the protractor and measuring out distance. This distance comes somewhere around 100 km. And obviously train travel in distance in 4 hours. So, for 100 km in 4 hours, therefore divide both sides by 4, I am getting 25 km in 1 hour. So, the velocity of train is 25 km per hour, but speed of train is 50 km per hour. This is the difference between speed and velocity. So, velocity is a vector, whereas speed is a scalar. It doesn't matter the change in direction, but velocity requires change in direction. So, here we can able to distinguish between speed of train and velocity of train. Same way, in vehicle also, whenever we are traveling, whatever given, that is not called as velocity meter, that is called as speedometer, because speed is measured from that. So, now it is clear that certain quantities require direction, and certain quantities are not required direction. So this is called as scalar and vector. Now let us discuss another fact. Now certain formulas. Now velocity may be constant, may not be constant. Suppose there is change in velocity, then for that purpose we can say there is acceleration. What is acceleration? Rate of change of velocity. Let us check out. This is my initial velocity and this is the final velocity. Henceforth, keep in mind that vectors we are writing by arrow on the head. So this is initial velocity and this is final velocity. What is change in velocity? That is final velocity minus initial velocity. That is the change in velocity. What is rate of change of velocity? So what is the change in velocity in given time or in unit time? So this is called a rate of change of velocity. So it is v minus u upon t. What is that? That is equal to acceleration. Now acceleration, suppose u, case number 1, that initial velocity is greater than final velocity, then you will get answer as negative. Then we are calling that as retardation. Vector acceleration only, but that is called as retardation. Suppose u is less than v, that means initial velocity is less than final velocity, then we are calling this as acceleration. Just try to recollect, if you are driving out vehicle, automobile, then there is a object that is called as accelerator. What is the role of accelerator? That increase the velocity. So this is when u is less and v is greater, then that is called as acceleration. If u means initial velocity is equal to final velocity, then numerator will be 0. Divide 0 by any greatest figure in the world. Answer is 0. Therefore, acceleration is 0. Therefore, keep in mind, whenever object is performing uniform velocity, the acceleration is 0. And therefore, keep in mind always, whenever uniform acceleration is uniform velocity is there, always acceleration term is 0. So this is about acceleration. Now you are aware of certain units. We are discussing along with this only. That what is the velocity we are writing? The SI unit for velocity, that is equal to meters per second. Before this discussion, we had discussed kilometers per hour. Yes, that is true. But for scientific purpose, we are taking this as meters per second. Can I convert kilometer per hour into meter per second? Answer is yes. Just check out. You are aware 1 kilometer is equal to 1000 meter. Divide by 1 hour. 1 hour is equal to 60 minutes. And 1 minute is equal to 60 seconds. So 60 into 60 seconds. So 1000 meter per 60 into 60 seconds. I have to convert it into per second. That is per 1 second what is the velocity. So I have to divide this side by 60 into 60, that means 3600. So I have to divide this side by 3600. Both way I am dividing. Are you able to follow? Numerator and denominator both are divided by same figure. So that is equal to, I am cancelling out this 1000 by, what is unit? Meter per second. So simply we can calculate 10101010 cancels out. This is 10 by 36, that is equal to 2 5 18, and therefore I can convert kilometer per hour, that is equal to 5 by 18 meter per second. Suppose you are aware velocity of certain object is 100 kilometer per hour. Calculate in terms of second. How we are going to solve this? The velocity is 100 kilometer per hour. That is equal to 100 into 5 by 18 meter per second. Just now we have calculated this. So just carry out this calculation, you will get clear cut answer in terms of meter per second. So carry out this calculation. So that is equal to 250 upon 9, 9 ones are, so you will get recurring always 0.777, so we are simply converting out as 27.778 because last decimal is greater than 5. Then while rounding up, I have to increase by 1. So it is 27.778. Suppose last digit is less than 5. Then how to round up? Increase, keep it as it is. Suppose our answer is 27.774 and I have to round up. What I should do? Simply remove this. Suppose answer is 777. What I can do? Remove this and increase this figure by 1. But suppose answer is like this, 775. This number is greater than 5, I have to increase. Less than 5, I have to keep it as it is. But that is equal to 5. Then observe previous figure. If this number is even, keep it as it is. If this number is odd, then add 1. So here if it is 775, then I have to make 8. Now on basis of that, this is in terms of meters per second. So this is very fundamental calculation. We are converting out we are converting out kilometer per hour to meter per second. Now next entity we have to discuss. That next entity is force. So force, this is also vector. Force is equal to mass into acceleration. Now what is unit of mass? You are aware, in SI system we are considering unit of mass as kilogram, or say that is MKS, meter, kilogram and second. So here we are considering mass in terms of kilogram. So we are discussing out now units along with formulae. So force is equal to mass into acceleration. Therefore force, what is unit of mass? That is kilogram. And unit of acceleration, now you are aware, that is meter per second square. You can observe on mass there is no arrow sign. That means mass is scalar quantity, but on acceleration there is arrow, so that is vector. So force is equal to, what is the unit we are discussing? Kilogram meter per second square. So I can write this unit as kilogram meter per second square, or this way also we can write kilogram meter per second square. Now lot of work is carried out by Sir Isaac Newton on this force, displacement, etc. And so in order to honor him, we are giving name of Newton here. So I am substituting this as Newton. So what is 1 Newton? 1 Newton is equal to kilogram meter per second square. So this is called as 1 Newton. So this is the unit of force. So I am writing here unit of force. I am writing in both the ways. Number 1, it is kilogram meter per second square, and that is equal to 1 Newton, or simply we can say that is equal to Newton. Now this is in MKS system. Suppose I have to convert this into CGS, then you are aware that 1 kilogram means 10 raised to 3 gram. 1 meter is equal to, now it is CGS. CGS stands for centimeter gram second. So that is equal to 10 raised to 2 centimeter. Centi 100. So this. And whether NKS or CGS, second will remain as it is. So this is equal to 10 raised to 5. Say 10 raised to 3 into 10 raised to 2. 10 raised to 5 gram centimeter per second square. So here kilogram meter per second square, here gram centimeter per second square. That is called as, we are writing in terms of dyne. As this is CGS unit, we are making this d in terms of small. So you are aware that CGS unit also we are writing here, that is equal to gram centimeter per second square, that is considered as dyne. And you are aware the conversion factor, that 1 Newton is equal to 10 raised to 5 dyne. So you can take this down, and conversion factor also you can keep in mind, 1 Newton is equal to 10 raised to 5 dyne. So this is about units of force. So we have discussed the force in terms of kilogram meter per second square, that is equal to Newton, and gram centimeter per second square, that is equal to dyne. This is in MKS system, this is in CGS system. Usually we are using this unit only. Now you are aware velocity, you are aware acceleration, we are aware force. Now we have to find out another concept, or we have to discuss simply another concept, that is work done. Now work done is having different concept in physics. What is the definition? If you are applying force and displacement is carried out in direction of force, then only it is considered as work done. So suppose I am having this pen in my hand, I am holding out this pen in my hand and standing here for 1 hour. Can I say that I have performed work? Answer is that no, because I am applying force but displacement is not there. Just I am holding out this pen, I am applying force in opposite direction of gravity, but there is no displacement. I am standing here for 1 hour, 2 hours, or n number of hours. There is no work done according to physics. Same way, suppose I am saying that I am taking this pen and throwing away. Can we consider this as work done? Answer is yes. According to physics, this is work done, because I am applying force and pen is moving, that means displacement is carried out in pen, and therefore we are calling this as work done. So what is work done? That W is equal to, we are applying force and displacement is carried out in the direction of force, then that is called as work. So work done is equal to force into displacement. Now this is also scalar vector quantity. Now here S is not second, this is displacement. So force into displacement, and that's why that example is valid. Suppose I am holding this pen for 1 hour, then I am applying force on this pen, but what is the displacement? 0. And therefore we have to say that as this is 0, work done is 0. So if displacement is there, then only we can say there is work done. Now we have to find out unit. Now you are aware the unit of force, that is kilogram meter per second square. And unit of displacement, whenever we are saying displacement, then unit of displacement, that is meter. So into meter. So this is kilogram meter square per second square. So this is the unit of work done, that is honored as Joule. Scientist name is there, and so we are giving unit of work done as kilogram meter square per second square, but simply symbolizing as Joule. Now CGS unit will be obviously gram into centimeter square into per second square, per second square we can write. Now this is considered as ergs. Again keep in mind capital MKS system, small CGS system. Now find out relationship between Joule and erg. So 1 Joule is equal to 1 kilogram into 1 meter into 1 meter into per second square. Now second square will remain common. So this is 1000, or simply in our concept we can write 10 raised to 3 gram into 10 raised to 2 centimeter into 10 raised to 2 centimeter per second square per meter is equal to 10 raised to 2 centimeter. Why I am writing purposefully separately in order to avoid confusion of meter square, that 1 meter into 1 meter. So simply we can say this is 10 to the power of 7 to 10 to the power of 2 into 10 to the power of 2, that is 10 to the power of 4 into 3. So 10 to the power of 7 gram. Now centimeter into centimeter, centimeter square into, that is equal to ergs. And so 1 joule is equal to 10 raised to 7 ergs. So we have now unit for work done, that is equal to, that is equal to kilogram meter square per second square, that is considered as joule, whereas gram centimeter square per second square, that is considered as ergs. First is obviously MKS and second one is in CGS, or in case of SI we are considering the first one. So this is the another concept we have discussed, that is the concept of work done. Now capacity to perform work done is called as energy, and that's why energy is also having same unit as joule and erg. Many people confuse between energy and heat. Heat is different and energy is different. No doubt that heat is form of energy, but always energy means not heat. Various forms of energy are available. Out of that, one is heat. And so heat can be explained in terms of erg, but many times we are using unit as calories and kilocalories in order to explain the heat. Now this is about joule and erg. So we have discussed now from initial velocity, final velocity till work done. We have discussed these fundamental things are very, very essential whenever we are discussing out certain concepts in physics and chemistry. Now one more entity I have to explain, that is momentum, small p. Now what is momentum? That is mass into velocity. So mass into velocity, that is called as momentum. Unit we can able to write down very easily, mass that is kilogram and velocity that is meter per second. So unit of momentum is kilogram meter per second. No scientist name is associated with it. So keep in mind simply MKS unit, that is kilogram meter per second, and CGS unit, that is gram centimeter per second. So I can write down this as gram centimeter per second. Now this is small p, whereas power we are writing as capital P. Now work done in unit time, that is called as power. So time factor is very, very essential. As time factor increases, what is the power we are writing? That is equal to work done in unit time. So it is W by T. So simple thing that as denominator increases, power decreases. Work done is same. Suppose 10 joule work is carried out in 1 second. So what is the power? That is equal to 10 joule per second. Suppose 10 joule work is carried out in 10 seconds. Then what is the power? That is equal to 1 joule per second. And so power factor is very important, that is work done in unit time. So what is the unit? That is joules per second. So I am writing this as capital P. Now this is the problem of English, especially alphabets, that small p and capital P we are not able to distinguish. So power, the unit is joule per second. Now instead of writing joule per second, we are writing this as watt. So that joule per second, that is equal to watt. Now from P we have discussed momentum also, power. Then another entity that is called as pressure. What is pressure? The force acting in the perpendicular direction. Perpendicular means making angle of 90 degree. So if force acting in perpendicular direction on definite surface area, then that is called as pressure. So pressure, now I am particularly writing here pressure, actually P, but purposefully because always you should not confuse. So pressure is equal to force acting in particular area. Now unit of area is meter square. So force acting in particular area. So what is unit of force? That is Newton. And therefore we are writing out pressure as Newton per meter square. So this is SI unit of pressure. Now another basic unit we have to discuss. Now as I am using word as basic, actually certain units, they are called as fundamental units and certain units are called as derived unit. Now as we have discussed here, time, only second. So this is called as fundamental unit. In case of length or displacement, we are calling this as in terms of meter, fundamental unit. Okay. Whereas all other units are derived unit. Mass, kilogram, that is the fundamental unit. But force, kilogram meter per second square, that is called as derived unit. So one more fundamental unit we have to discuss here, that is the temperature.